All right, today we are going to learn a shortcut to dividing polynomials, and the shortcut only works for when you're dividing by a linear term. So as you see right here, got a couple lingering people talking about college here. You ready? That's right. Okay. So we're going to divide a quadratic, this 7x squared minus 23x stuff, divided by x minus 3, so it's being divided by a linear term. So when you're dividing by a linear term, we can use the synthetic division shortcut. So let's give it a whirl. So what we have here, let's see. Whatever makes the stuff you're dividing by, so like we're dividing by x minus 3, whatever makes that 0 for x, which would be 3, we put that in this little box thing over here. The rest of it is going to be filled out by the coefficients of each term in the polynomial we're dividing. So this polynomial we're dividing, it has a degree of 2. So it's going to have a quadratic term, a linear term, quadratic term, linear term, constant term. So it should have 3 terms. Sometimes a term might be missing, so you'd have to add a 0 in there if it was missing. All right, so none are missing there. So the coefficient of the quadratic term is 7, the linear term is negative 23, and the constant term is 6. The way this always starts off is this first coefficient comes straight down here and starts everything off down here like that. Now we take the number in the box 3 times that 7, which is 21. We write that number right here. And now we add those two, negative 23 and 21 together. And we get negative 2. Now the process starts over. Take the number in the box 3 times the negative 2, which is negative 6. Record that there and add the one above it. So 6 minus 6, or 6 plus negative 6, is 0. I got the negative 6 by taking this times that and putting it there. Right? The one previous to that, I took the 3 times the 7 and got 21 and put it there. Know what I mean? The previous one, I just pull that straight down and start it off. Okay, so that's kind of messy there, so we'll get rid of that. So now the last term, the last number that we have is the remainder. So that is over x minus 3. Keep working to the left. The next term is the constant. So, technically it's x to the 0, but nobody ever writes x to the 0 because x to the 0 is 1. So that's the constant. So really, we don't write any x there. And the next term over the 7 is the linear term, so that is the x. So that's your quotient right there. We took a quadratic divided by a linear, and our answer was a linear. So that is equal to 7x minus 2 with a remainder of 0, so we don't write the remainder in. It's kind of slick, eh? Who votes that is slick? 1, 2, 3, 4, 5, 6, 7, 8. About 8, about half. A little less than half. That's not bad. Let's try it again. What number goes in the little box here now? Negative 2, because that's what makes the stuff that you're dividing by equal 0. And it has to be linear, so put negative 2 in the box. And then write your coefficients out. This is a cubic, so we're going to have 4 of them. There's always one more than the degree. So Cubic term is 1. The next term down, quadratic, second degree is -5. The linear term is 2. The constant term is -7. Again, if you're missing any terms, like if there wasn't a squared term or a quadratic term, you'd have to put a 0 in there. Okay, how do we start it out, Dave?
You bring down the 1.
Bring down the 1. Good. Nice job.
Then you multiply that 1 by that -2.
Multiply that 1 by that -2 there. Write that there, right?
Yep.
See that, Sid?
Nope.
So we always start by bringing the 1 down right there like that. And then to get this next number here, we take the number in the box times that 1 that we pulled down. So -2 times 1 is -2, and we write that number right there. Okay, next step. Sid, what's the next step? Good, so we add them, right? So -5 plus -2 is -7. And now we just start over with the number in the box times the -7, 14, and now we add them again. 2 plus 14 is 16. Start over, take that -2 times the 16, and we get -32. Add those puppies, and we get a remainder this time of -39. The last number is always your remainder. That is going to be over x plus 2. Working your way back to the left, this 16 is the constant. The -7 is the linear term, so we put an x there. And the 1 is the quadratic term, so we put an x squared there. Right? If it's positive, that's a plus. I mean, how slick is that? Synthetic division. Are we good? Moving on. One more. Let's do one where we have to add some zeros. Now we got some missing zeros. We're taking a cubic that has a trinomial, cubic trinomial, so it's missing a quadratic term. Dividing by a linear again. What goes in the box here? 2, because that makes the linear term we're dividing by 0. Write your coefficients out there, so it's a cubic, so I start with a 1. Quadratic term is missing, so I add a 0. Linear term is a 2. Constant's a -1. Okay, I'll give you a little head start there and see if you can't get this one all by yourself. Oh, Canada, we're back. All right. Okay, so let's see if you got that one right here. Pull the first number down. We get a 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 2 plus 4 is 6. 6 times 2 is 12. Remainder of 11. Who got it right? Did you get it right? Good. That remainder would be over x minus 2. This is the constant 6, so there's no x. 2 has an x. 1 has an x squared. Plus, plus, plus. Look at how slick that is. Any questions? What do you think about that synthetic division? That's pretty slick. Way better than long division. Yep. Okay. Yep. We're almost done. Couple more things. Looking ahead, we're going to use this to start factoring higher degree polynomials. So we will we'll use this to start writing a polynomial with all of its factors. So we'll use like synthetic division once and then twice and then maybe even a third time to divide a polynomial up into all its factors. One thing that you need to realize here is this remainder theorem, which basically means if you have a remainder that's 0, what that means is it divides it in evenly, and so that term was a factor. So like, think about a number. Let's go 20 divided by 6. Is 6 a factor of 20? No, because when you divide 20 by 6, you get a remainder of 2, right? It's 3 and 2, 6. So in order for something to be a factor of something, it has to have a remainder of 0. Right? So if we just look back to some of the previous things, was x minus 2, is this x minus 2, is that a factor of x cubed plus 2x minus 1? No, it's not a factor because the remainder was not 0. Okay. All right, let's go back another page. Was x minus 3 right here at the top a factor of 7x squared? Yeah, because it has a remainder of 0, so now it's a clean factor with no remainder, right? So that's what that's saying, is if it has a remainder of 0, then, oh, hey, that's a nice perfect factor there. All right, the last little bit is another application of this is you can use it to evaluate functions. So if we have a polynomial function, and here's an example from the book there, and then here's the example that we ask you to do. So let's say we wanted to evaluate the polynomial function x cubed plus 3x squared plus 4 for x equals negative 3. We can use it's called synthetic substitution. We can use this to evaluate that. So negative 3 there, we put a 1, a 3, a 0 because there's no linear term, and a 4. And what the remainder ends up being is the value of the function when you substitute negative 3 in. So we go and we just do this. I don't know if this is any better than, sometimes it's maybe just as much work as just plugging in a negative 3 into the function. But you pull the 1 down, multiply, you get negative 3, 0, 0, 0, 0, 4. So when you put negative 3 into that polynomial, p of negative 3 is equal to 4. That's what we determine there. Okay? I don't know if that's really any easier than just putting negative 3 in. Negative 3 cubed plus 3 times negative 3 squared plus 4, right? You can it's the same thing. Negative 3 cubed, that's 27. Negative 3 squared plus or times 3, that's positive 27. So negative 27 plus 27 plus 4 equals 4. So you get the same thing either way. So synthetic substitution, you can use it to substitute or to evaluate polynomials as well. I don't know, kind of cheesy. Not as great as using it to divide, I don't think. All right, so that is a wrap on 6.3. So nice job, Meow.